3.4 is on scientific notation. And if you had me in 6th grade, you'll remember this is when we started to use the word dinks. So a number is written in scientific notation if it is in the form of c times 10 to a power, where 1 is less than or equal to c, which is less than 10, meaning that your number value has to have a value that's between 1 and 10. Okay, so if we rewrite each one of these in decimal form, we have 2.834. Again, notice I have one value before the decimal point. Okay, that's what we would use for scientific notation. And now because it's times 10 to the 10 squared, which is 100, I need to, when I multiply by 100, I add 2 zeros, sometimes we say, or we're going to move dink 2 times. So our finished answer will be 283.4. Okay, doing the same thing in this one, 4.9 times 10 to the 5th. I'm going to take my 4.9 and I'm going to move it the number of dinks that there is in the exponent. 1, 2, 3, 4, 5. This is why we use dinks instead of whooshes. And now I need to put some placeholders in there. So when I put those placeholders in there, every dink that didn't have something above it, I put a placeholder. And now I need to rewrite that number. And that number would be 490,000. So I'm going to write it nice and neat without the dinks and making sure that I add my comma so that I can read that number correctly. Now in letter C, we're going to talk about a negative exponent as we were working in at the beginning of the chapter. So if it is 7.8 times 10 to the negative 1, instead of making my dinks go to the right, I'm going to make it go to the left. Now, I would caution you on just thinking left and right, because I would also tell you I want to make, if this number is a negative exponent, that's the same as if I would change that to its reciprocal. And if I multiply by the reciprocal there, 10 to the first is going to go this way, I'm going to make that number get even smaller. Okay, so I want to make it, that's what helps me remember which way I'm moving that. Now I'm going to write it cleanly without any dinks. Give it a 0 in front of the decimal point so that you can see the decimal point there, because my dink ended up here. Right, 1.23 times 10 to the negative 6. So I take my decimal point, I want to make it smaller. 1, 2, 3, 4, 5, 6. I want to fill in my placeholders. And my decimal point is going to end up right here. So when I rewrite that, I'm going to put my 0 first. And I have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. And then I'm going to put my other digits back in there. 1, 2, 3. Now, another good way to do it is you could do it in reverse and see if you end up with your beginning number again. So if I wanted to check my answer, I'll do it in red. And I said I went 6 was my exponent. So if I did 6, if that was 10 to the 6th, I go 1, 2, 3, 4, 5, 6, and I should end up with my original one again. So that's how you can check and make sure that you have dinked enough times. All right, so rewriting this time, we're going to start with our number and we're going to rewrite it into exponential form. So what we said was that we needed to have that value be that there would be one digit ahead of the decimal point. So I want my digit to be right here between the 3 and the 4. So to get my digit there, I'm going to count to see how many places I would need to move that digit. So right now, the original digit is here. And I'm going to move it, making it smaller. 1, 2, 3, 4 dinks to get to my new decimal point. Okay, so when I do that, I'm going to say to get to this value, 3.469, to get that value to the larger number, I'm going to give it a positive, and there were 4 dinks, so that's times 10 to the 4th power. Now we want our new decimal here. For the next one is 1.78. I want one value above the, before the decimal point. It is already there. So to write this one in scientific notation would be simply that 1.78. And that's going to be times, and we want it times 1. We don't want anything to change with that one. So to say it times 1 in scientific notation would be times 10 to the 0 power, because 10 to the 0 power equals 1. Now let's try a decimal, 0.039. For that one, I want it to turn out, so I want my decimal for scientific notation to be between the 3 and the 9. So in order to do that, I'm going to move my dinks, 1, 2, and now I have to think about what I'm writing here. My new number is 3.9. My original number was smaller. So if my original number is smaller, I want to use a negative exponent, and I had 2 dinks, so that would be times 10 to the negative 2. So write your new number, look at the number you start out with, is it bigger or smaller, and then that will tell you what kind of exponent, a positive or a negative exponent. So we'll just do a couple more here a little bit quicker. I want this to turn out to be 7.22. So I want it to get to be between here. I'll do my dinks, 1, 2, 3, 4. That is a bigger number, so I want that to be 7.22. And it started out as a smaller number, so I want that to be 10 to the negative 4. And then this one, we have a very large number. We're going to just change it to 5.6. Going to go ahead and count our dinks. And I end up with having 9 dinks. So that would be times 10 to the 9th. Continuing, we're going to talk about how we can calculate or compute using the scientific notations. The first expression we're going to look at is a multiplication one. And we're going to go back and do a property that we have not talked about for a while, the associative property, meaning we can regroup things. So we're going to regroup that with our decimals together and our scientific or our exponential expressions together. Okay, so now I just changed the groups around. When I'm doing that, then that will help me because I can go ahead and I can do 10 to the 7th here. And then I'd use my calculator for 1.4 times 7/6 most likely. And I would get my 10.64. Now I can apply my exponent rule here. And I would go ahead and move my decimal. So I want to move this so that I have my number would be with just one number ahead of the one value ahead of the decimal point. And in doing that, I would change my exponent to 8 because I moved one dink. Okay, we're going to do the same thing this time with division. So the first thing I'm going to do with division is I'm going to separate this into 2 different fractions. So it doesn't seem like a big deal here, but again, I'm grouping my like terms together. In doing so, I can get my decimals together and I can divide those out. I would get a 0.25. And then I will go ahead and I would combine these. This one, -1, would be the larger one. So I'm going to add 4 here and I would end up 10 to the 3rd. So now I have 0.25 times 10 to the 3rd. I want my decimal to be there, so I have 2.5. My original number is smaller than that, so I need to go down 1 with my exponent. So it's going to be 2.5 times 10 squared. Now my last one, I have a quantity. And so inside of the parentheses, and then I also have it raising to a power. So the first thing that I'm going to do is I'm going to apply my raising to the power. So I'm going to do 4 cubed, and then I'm going to do 10, and I have to the -2, and then I'm going to raise it to the 3rd power, so now I have a -6. I would multiply those. So the power of a product rule I applied first. Then I can go ahead and I can do some multiplying out. 4 cubed is 64, and that's times 10 to the 6th. I'm going to put my decimal in, so I have 6.4 times 10, and my original number was 64, so I actually am getting bigger, so I want to make this times 10 10 to the negative 5, because my original number is larger than my new number, 6.4. All right, the next example tells you how to use calculator to do this. So I think if you just pause and read it, you should be fine with that one. Again, some calculators can be slightly different, but I think you can figure out your buttons with that. And then also both of our real life or story problems, pretty much they go ahead and they explain this in what I have copied there. So and this is just your unit analysis. So you can see how they broke up the different kinds of information you would need. And then to multiply that, we'll go ahead and I would do, so we're trying to find the total amount of water. So I'm going to go back where we have our information. The total amount of water would be the 4.2 times 10 to the 6th, and that's cubic feet. And that's going to be in 1 second. We're going to multiply that, I guess I wrote my cubic feet a little too big, times 3.2 times 10 to the 7th. And again, that measurement is going to be 1 year. And I think when I looked at that, I forgot to label my 1 second here. That example is in the book worked out, and so you can go ahead and do that. That would, again, we'd apply the rules that I would put the 4.2 times the 3.2 together. I would group my 10 to the 6th with my 10 to the 7th. And then I would go ahead and multiply that out. I would get my, let's see, 1.344. And so I'll let you look in the book and it has that all out. This is the part that you would need to know is how you would set that up and where you're getting the information. And so then our last one, dividing with scientific notation, again, taking the information we have here and just understanding how to set it up. And then when we set it up, we would have had 7.2 times 10 to the 6th power, and that would be over 3.78 times 10 to the 8th power. Again, setting it up is what we would need to look for. Where did I get this information up in here? And then we've already talked about the process of you would separate your terms and simplify. And that finishes us off for lesson